Hello student, my name is Dr. F Fətullayeva. I am assistant professor at the General Hygiene and Ecology Department. Today we continue study about water hygiene, lecture 6, topic name Bacteriological parameter of water disease associated with water, water treatment, disinfection and other methods used for improvement of water quality in centralized water supply system, the sanitary protection source and water supply system. The natural water objects are not a native habitat of pathological microorganism. As a rule, the pathogenic microflora dies in water during certain time. However, some pathogenic microorganism can keep vital function and even reproduce itself in water. Duration of pathogenic microorganism survival in water depends on composition of water, presence and concentration of biological substrate, property of microbial cell, water temperature, insolation intensity. Data of different analyses of pathogenic bacteria survival times in water are quite contradictory. In experimental condition, pathogenic organisms of listed infections stay alive in water during several months. In natural condition, bacterial pollution is exposed to quick and intensive deletion. Therefore, not numerous pathogenic microorganisms are opposed enormous number of their antagonists, saprophytes, and soon the pathogenic organisms are eliminated. Practically, main source of bacterial water pollution are man feces, which contain the enteric infection pathogenic organism. Therefore, at the sanitary analysis of water, all attention concentrates on determination of fecal pollution factor. As parameter of water pollution by feces is Colibacillus, living in human and animal intestine. Using the Colibacillus as indirect parameter of water pollution by pathogenic bacteria of the enteric group is proved by series of circumstances. The Escherichia coli is the indicator of fresh fecal water pollution. It has a good stability in environment in comparison with typhoid and dysenteric bacteria. It's easy for methodological identification. The other kind of enteric microflora, enterococci, spore anaerobes, are less appropriate in that sense. Result of Colibacillus determination in water are described in the form of coli index, coli titer, and microbial number of water. Coli index, the number of non-pathogenic intestinal bacteria, is 1 of drinking liter of drinking water. In centralized water is not more than 3. In local water is not more than 10. Coli titer. Coli titer is the minimum quantity of water in which there is the 1 intestinal bacteria. In centralized water is not less than 300 milliliter. In rural area it's not less than 100 milliliter. For converting coli index to coli titer, it's necessary to divide 1000 by value of coli index, and for converting of coli titer to coli index, it's necessary to divide 1000 by value of coli titer. Total count of bacteria in 1 milliliter, or microbial number of water, is a quantity of bacteria grown on nutrient medium at solving of 1 milliliter of testing water. For centralized water is not more than 50, and for local water source 300, 400. A long time ago, the correlation between morbidity of population and water factor was observed by people. Especially water factor has an important role in spreading acute enteric infection and invasion. Epidemic, from Greek language general disease, is a category of intensity of the epidemic process characterized by the rate of certain infectious disease morbidity, which exceeds the usually registered rate in the given territory of a certain period of time. Next slide include information about main disease transmitted by water. This intestinal infection of a bacterial origin, viral infection, protozoal, leptospirosis, very dangerous disease, cholera, bacterial zoonosis, and others. Main symptom of water epidemic. Simultaneous appearance of big number of infected people, jump of population morbidity, so-called epidemic outburst. People who use the same water source, the same pipeline or water supply network, the same water pump, shaft, will suffer from disease. Morbidity level will stay high for a long period of time to the extent of water contamination and consumption. Morbidity curve will have 1, 2, 3 or more peaks. First of all, those diseases that have short incubation period will be registered. For example, cholera, salmonellosis, incubation period 1-3 days, cholera 1-5 days, typhoid 14-21 days, and at last, with the longest period, virus and epidemic hepatitis A and E. Incubation period equal 30 days and more. Next symptom of water epidemic, after the taking of anti-epidemic measures, liquidation of the contamination source, disinfection of water supply network, sanitation of well, the outburst fades away and morbidity goes down drastically. Still for some time morbidity remains above the sporadic level, so-called epidemic tail. This is caused by the appearance of big amount of new potential source of infection, sick people and infection carriers during the epidemic outburst and activation of the other ways of the pathogenic microorganism spreading from this source, domestic contact, through dirty hands, dishes, children's toys, personal hygiene articles, through food or by living carriage flies. Very dangerous disease spreading by water, cholera disease. The endemic center of cholera now is the area of Ganges and Brahmaputra rivers in India and Pakistan. For last 10 years, the mortality from cholera is considerably decreased because of the Asian cholera is gradually forced out by cholera caused by B type A and the Vibrio actor. The Vibrio actor causes the less severe clinical form of disease, but is kept longer in environment and is increased the epidemic risk. Cholera prevalence last year was caused by incomplete organization of water supply, infringement of the international quarantine standard, intensive migration of the people, choleric vibrio carriage, a healthy carriage of biotype actor from 9.5 up to 25%, and also rapid transportation of the polluted products and water by air and water transport. The water factor in disease spreading is especially characteristic for typhoid. The typhoid bacteria keeps in flowing water till 7-10 days, in wells up to 1 month and more, in eats up to 2 months. Before the centralized water supply implementation, the water epidemic of typhoid were usually for Europe and American cities. The big water epidemic of typhoid took place in Rostov City, Russia, in 1927 as a result of sewer drains damage and sewage getting into the water supply system, and Krasnodar in 1928. Paratyphoid water epidemic as independent epidemic happen extremely seldom and usually accompany the typhoid epidemic. Long time was considered that with dysentery is spread exceptionally by alimentary, nutritional, or contact ways. However, a considerable number of dysentery epidemics were registered after use of poor quality drinking water. There are large epidemics of bacillus dysentery registered in the USA, 1926, and Japan, 1937. Episodes of dysentery are as a result of damage of water purifying system pollution of wells by flood water and injuries of sewage to water supply system. As water infection, the icteric bacillus disease and anicteric leptospirosis and tularemia are considered. The icteric leptospirosis is occurred worldwide, especially in East and Southeast Asia. The people usually catch this infection as a result of swimming in polluted water reservoirs or contact to polluted water during summer field work. Moreover, the water drinking epidemic of leptospirosis are also known. Carriage of leptospirosis are rodent, 38.9%, pig, dogs, 26.6%, and cattle, 2.3%. The epidemic episodes fall into the summer-autumn season, a period of frequent contacts of people to polluted water. Drinking and swimming water can be a source of majority virus infection spreading. Now the observational series about role of water factor in spreading of infection, polymyelitis, and other enteroviruses and adenoviruses infection test show that the main reservoir of enteric viruses in environment are feces and the economic household sewage infected by them. The risk of virus transmission by waterway is more perceptible by the example of infection hepatitis. Hepatitis A. There are 1.5 million causes of clinical hepatitis A every year. The largest water epidemic of infection hepatitis was registered in 1955-1956 in Delhi, India, and affected nearby 29,000 people. Cause of epidemic was tap water pollution by sewage. Fecal pollution of water is the main cause of emergency transmission. Amoeba was isolated from off-ground and treated sewage and from water of the surface water reservoir. In pure water, amoeba cyst keeps in vitality till 153 days. The Lambriet cysts are also presented at water. The carriage of this disease is widely spread all over the world and reach up to 20% of population in different countries. The Lambriet cyst in water can be cause of enteric disorders as lingering diarrhea. The water has a special role in spreading of helminthiasis and ascarias, schistosomiasis, dracunculosis. Schistosomiasis is a disease at which helminths live in the venous system. Migration of this blood flow to the liver and to the urinary bladder can cause of serious consequences. Usually the virus occurs in rice fields during swimming in shallow water reservoirs, river, lake, which water is infected by grub stage of helminths. The grub gets into the human organism through the intact skin. Scab of swimmer is a dermal disease. Invasion occurs at swimming in incirculating water reservoirs where live infected snails, the breeding species of schistosomiasis. According to the World Health Organization data, schistosomasiasis is a prevalent and approximately 200 million of population all over the world, mainly of Africa, Asia, and Latin America, annually are affected by this disease. Next, dracunculosis. Dracunculosis guinea worm is a helminthiasis affecting the skin, the hypodermic fatty tissue, and has a well-defined allergic component. Invasion occurs when people use the water infected by cyclops. Before drink water in the water source, clearing or treated, and after disinfection. In the hygienic practice, for increasing water quality, applied next method. This method divided two groups. Basal method include water clearing and discoloration, and disinfection, and special methods. The basic purpose of water treating, protection of the consumer against pathogenic organisms and impurity which can be dangerous to health of the person or has unpleasant property, color, smell, taste. Method of cleaning should be chosen if due of quality and character of a source of water supply. Use underground interstitial water source for the centralized water supply has a lot of advantages before use of superficial source. To measure of them concept, security of water from external pollution, safety in the epidemiological attitude relation, a constancy of quality and water discharge. Water discharge is the volume of water acting from a source in unit of time. Usually underground water do not require clarification, discoloration, and disinfecting. It is a lot of method of improvement of quality of water, and they all lead to the risk, except water from the dangerous microorganism, were weighted particles, humic compounds from supplies of salts, toxic and radioactive substance, and foul-smelling gases. Water purification process consists of three stages: precipitation, water coagulation and flocculation, and water filtration. The coagulation is used to accelerate the sedimentation of suspended matter, filtration and lengthening of water. They add the Falleyum coagulator to water, aluminum sulfate, iron sulfate. They form insoluble compounds with the dissolved electrolytes, which are quickly sediment as flux. These flux have a large active surface, a positive electric charge. That's why they absorb even the smallest negative microbe particles and colloidal humus, taking them to the bottom of the settling tank. The transparent and uncolored filtrate is formed after the sedimentation of flux and the next filtration of water. The use of coagulator allows decolorizing water to shorten the time of setting to 3 hours and to use fast filters. 95% warm eggs, 90% and more bacteria and viruses are left to water after the coagulation and setting. Coagulation belongs to the most effective method of water clearing from viruses. Lately, we have been using large molecular matters, flocculants, activated salicylic acid, which are active in very small doses, 0.2 to 2 mg/liter, to accelerate coagulation and economize the coagulator. 5% solution of the coagulator is given to the mixer with the help of special dosator, where it's quickly mixed with. Then the water enters the reaction chamber, where the formation of flux completes in 10-20 minutes. Such water passes to the setting tank, where the flux are sediment. The size of setting tank corresponds to the setting for 2-3 hours. According to water direction, the horizontal and vertical precipitation tanks are distinguished. The vertical precipitation tanks are used in water works of small productive capacity, because for effective precipitation, the water speed there has to be small, about 1 mm secondary. The horizontal precipitation tanks are used in water works of large productive capacity. The water speed where is bigger than in vertical tanks, about 2-4 mm secondary, and is increased by coagulation up to 6-8 mm/hour. The next stage is the removing of fine dispersed suspended matter from water. It's filtration. The essence of filtration in water passing through the finely porous material which detains the suspended matter. As the main filtered bed, the fine sand and gravel are usually used in filters. Filtration is important because 98-99% of bacteria are removed by filtration, apart from other impurities. Next, filters applied for water filtration: slow sand filter, rapid sand filter, double rapid filter, contact grapher. Following are the elements of a slow sand filter or biological filter. Supermannatant raw mud water is present above sand bed. Its depth varies from 1.5 meter. It serves two important functions. It serves as a constant supply of water. It provides waiting period of some hours, and there is partial purification by sedimentation and oxidation. And sand bed is the most important part of the filter. Its thickness is about 1.2 meter. The sand grains are of diameter between 0.50 and 0.35 millimeter. Sand bed is supported by a layer of graded gravel. Water percolates through the sand bed very slow, and during this it is subjected to a number of purification processes: mechanical strengthening, sedimentation, absorption, oxidation, and bactericidal. Next kind of filter, double rapid filter. Speed of water 15 meter/hour. Efficiency 75%. They are usually used in big cities. After double filter, the water needs for disinfection. According to the number of the filter beds, the single layer and the double layer filters are distinguished. The grapher is a kind of rapid filter. It units at once three processes: coagulation, precipitation, and filtration. Filtration speed is 4-5 meter/hour. Today, in the water source, applied very new modern filters. This newest technology of water purification by track membrane triggered. This purifying system is a full analog of living organism cell membrane. Track membrane has the same micropores and all water pollutants with size more than 0.2 micrometer are detained on their surface. Track membrane is made of polymeric films with the solidity 23 micron by means of bombarding it with high energy krypton ions that pierce the film all the way through. Destruction material channels, tracks, are created at the space of separate ions. This material is different from the unpierced ones with its physical and chemical properties. Strongly equal through holes of cylindrical shape form in position in the track, then etching the film process with ions is the alkaline solution. A particular accelerator is used for the mass production of track membrane. The main difference between the track membrane and other types of membrane is the high selectivity of the first ones. All single pairs have the same exact diameter with maximum 5% diffraction. That is why, depending on the functional purpose, filtration of mechanical admixture, bacterial or virus substance, the corresponding rating of the track membrane can be chosen, which would the optimal for the certain process of microfiltration. Usage of the track membrane for the drinking water purification in house-cooled and extreme conditions is one of its applied adaptation. According to the researchers, the optimal purse diameter for use in the above mounting condition is 0.2–0.4 micron. With such porous diameter, the most widespread hazardous substances present in water are filtered out, and on the other hand, the water returns microelements that are vital for human organism After water cleaning or purifying, water needs for disinfection. Water's method disinfection divided to group physical and chemical. Physical boiling, UV rays, ultrasound waves, electromagnetic waves, gamma rays, chemical chlorination, ozonation, and silvation. The disinfection is one of the most usable methods of water improvement. The task of disinfected, destruction of pathogenic microorganisms, maintenance of epidemic safety of water. Usually it's concluding and very important stage. Chemical decontamination method and very important chlorination. Russia was one of the first countries in whom chlorination of water began to be applied on water pipes. There was it in 1910. However, at the first stage, chlorination of water spent only at flushes of water epidemics. Now, chlorination of water is one of the most widespread preventive action. Played a high role in the prevention of water epidemic. This is promoted by availability of a method, its cheapness and reliability of disinfected, and also a multivariant approach. An opportunity to disinfect water on a waterworks mobile installation in wells, on field camp, in a flag. The principle of chlorination is based on processing water by chlorine or the chemical compounds containing chlorine in the active form, processing oxidizing and bactericidal action. The chemistry of a curing process will be that at addition of chlorine to water, there is hydrolysis, are formed hydraulic and hydrochlorous acid. It all hypothesis explaining the mechanism of bactericidal action of chlorine. Hypochlorines acid are located in the central place. The small size of a molecule and electric neutrality allow hypochlorous acid to pass quickly. Hypochlorous acid to pass quickly through an environment of bacterial cells and to influence cellular enzyme, important for a metabolism and process of duplication of cell, is confirmed an electronic microscopy. Damage of environment of cell, infringement of its permeability, and reduction on volume of cells is revealed. On large water pipes, to chlorination apply the gaseous chlorine acting in steel cylinders or tanks in the liquid kind. Use as a rule a method of normal chlorination, on chlorine need. Has great value a choice of the dose providing reliable disinfectant. At disinfected water, chlorine not only promotes destruction of microorganisms but also cooperates with organic substances of water and some salts. All this form of linkage of chlorine and unitive in concept chlorine absorbability of water. According to sanitary norms and rules, the dose of chlorine should be such that after disinfected in water 0.3–0.5 mg/liter of free residual chlorine contained. This method not worsening taste of water and not being unhealthy testifies to reliability of disinfected. Amount of active chlorine in the milligram necessary for disinfected 1 liter water named chlorine need of water. Except for a correct choice of dose of the chlorine, a necessary condition of effective disinfectant is good hashing water and sufficient time of contact of water with chlorine. In the summer, not less than 30 minutes. In the winter, not less than 1 hour. Next method of chlorinization applied: double chlorinization, chlorinization with ammonization, hyperchlorination. Double chlorination provides submission of chlorine on a waterworks twice, first time before sediment balls and the second, as it is usual, after filters. It improves coagulation and decoloration of water, suppresses growth of microflora, including construction, and increases reliability of disinfected. Chlorination with ammonization provides introduction is disinfected water of a solution of ammonia and in 0.5 to minutes chlorine. Thus, in water are formed chloramines, monochloramines, and dichloramines, which also possess bactericidal action. This method is applied to disinfect the water containing phenols, with the purpose of the warning of formation chlorophenols. Hyperchlorination method provides addition to water of obviously big doses of chlorine, 10-20 mg/liter and more. It allows to reduce time of contact of water with chlorine till 50-20 minutes and to receive reliable disinfectant from all kinds of microorganisms, bacteria, viruses, rickettsia, dysenteric amoeba, tuberculosis, and even dispute of a Siberian ulcer. After end of process of disinfected in water, there is a big surplus of chlorine, and there is necessity is dechlorination. Hyperchlorination method is applied mainly on exposition and military condition. It's necessary to attribute the last of a method of chlorination. Complexity of transportation and storage of liquid chlorine and its toxicity, long time of contact of water with chlorine, and complexity of selection of a dose at chlorination by normal dose, formation in water organ chlorine, connection and dioxins not different for an organism, change organoleptic property of water. Nevertheless, high efficiency makes a method of chlorination by the most widespread in practice of disinfected of water. In surface reagent-free method or the reagents which are not changing a chemical compounds of water have paid attention on ozone. For the first time, experiments with definition of bactericidal property of ozone conducted in French to 1886. First ever industrial ozonizing device has been constructed in Petersburg in 1911. Now the method of ozonation of water is one of the most perspective and already application in many countries of the world. French, USA. Ozone gas of a pale violet color with a characteristic smell. A molecule of ozone easily cleaves atom of oxygen. Atomic oxygen and free radicals, being strong oxidizer, cause bactericidal property of ozone. Alongside with bactericidal action of ozone during processing water, there is discoloration and elimination of smoke and smell. Ozone received directly on a water works by the sealing electric category in air. Installation for ozonation of water units block or an air conditioning, reception of ozone and its mixture with disinfected water. An indirect parameter of efficiency of ozonation is residual ozone at a level of 0.1–0.3 mg/liter after the chamber of mixture. Advantages of ozone before chlorine at disinfected water will be that ozone does not form in water of toxic connection, improves organoleptic parameter of water and provide bactericidal effect at smaller time of contact, up to 10 minutes. It's more effective in relation to the pathogenic elementary, a dysenteric amoeba, lamblia. Wide introduction of ozonation in practice of disinfected of water restores high power consumption of process of reception of ozone and imperfection of the equipment. Third method silversion. Oligodynamic action of silver for a long time was considered as a means for disinfected mainly individual stock of water. Silver process expressed bacteriostatic action, even an introduction in water of a significant amount of ions of silver microorganisms stop duplication through remain alive and even capable to cause disease. Concentration of the silver capable to cause destruction of the majority of microorganisms at the long use of water are toxic for the person. Physical method of water disinfection include irradiation to ultrasonic waves, ultraviolet beams, current of higher frequency waves, gamma, boiling. Advantage of physical method of disinfectant before chemical will be that they do not change a chemical compounds of water, do not worsen its organoleptic property. Ultraviolet beams process bactericidal action. It has been established at the end of the last century by researcher McLanoff. The site of the UV part on optical spectrum in wave and from 200 up to 275 nanometer is maximum effective. The maximum of bactericidal action falls at beams with length of a wave 260 nanometer. Mechanism of bactericidal action of a UV irradiation now explain break of communication in enzyme system of a bacterial cell, causing infringement of a microstructure and a metabolism of the cell resulting to its destruction. Dynamic of dying of microflora depends on the dose and the initial contents of microorganism. Efficiency of disinfectant influences a degree of turbidity, chromaticity of water and its salt structure. The necessary precondition for reliable disinfected water by UV beams is its preliminary classification and decoloration of water. Advantage of ultraviolet irradiation that UV beams do not change organoleptic property of water and possess wide spectrum of antimicrobial action, destroy viruses, dispatch of bacillus and egg helminths. Next physical method of disinfection, ultrasound method. Ultrasound method applied to disinfecting household service since its effective concerning all kinds of microorganisms, including the species of bacillus. Its efficiency does not depend from turbidity and its application does not result in foaming which frequently take place in disinfectant household drains. Next, gamma radiation. Gamma radiation is a very effective method. Effect is instant. Destruction of all kinds of microorganisms. However, in practice of water pipes that does not find application. Boiling is in the simplest method of disinfection. Vegetative form of pathogen microorganism die in 20-40 seconds at a temperature 80 degrees. The water is almost disinfected until it begins to boil. 5 minutes of boiling provides reliable safety even in very strong pollution by suspended matter, viruses and other pathological agents. During 30 minutes of boiling, most of spores die too. The spores of anthrax, worm eggs and larvae are inactivated. Protozoa die too. This method is often used in the everyday life, in hospital, hospital institute, in the manufacturer's railway station. It's necessary to clean tanks before filling them with the boiled water or change water every day, as the microorganisms multiply here very quickly. Container is the boiled water is stored. It's necessary to wash daily and daily to change water, as in boiled water there is an intensive duplication of microorganisms. Today, for improvement drinking water at home, apply different kinds of communal domestic filter. For example, aqua filter. Method of improvement of quality of water. The traditional technology of water treating in water pipes poses a delimited barrier action concerning many chemical substances. Underground water very much frequently high mineralized, also required special cleaning. Special methods include water deodorization, deironing, softening, desalination, decontamination, fluoridation, defluorinization, chemical tablet method. Deodorization, elimination of smell, is achieved by aeration, processing by oxidizer, ozonation, the big doses of chlorine, potassium permanganate, filtering through the activated coal. Next method, special method, deironing method. Deironing is made by spattering water with the purpose of aeration in special devices, cooling stack. Thus bivalent iron is oxidized in hydrate iron, which is besieged in a sediment bowl and laid on the filter. Softening of water, next method, is achieved by filtering through ion exchange filter, loaded or cation resin, cation exchange, or anion resin, cation exchange. Next special method, desalination method. Water desalination technique, flash evaporation is the most widely used method of water desalination. The seawater is heated and then pumped in the low pressure tank where the water is partially vaporized. The water vapor is then condensed and removed as pure water. This process is repeated many times. The remaining liquid, cold breathed, contains a large amount of salt and is removed and often processed for minerals. Note that the incoming seawater is used to cool the condensers in each evaporator. This design converts energy since the heat released when the vapor condense is used to heat the next batch of seawater. Next special method, decontamination method. Decrease in the mountains of radioactive substance in water on 70–30% occurs at coagulation, upholding and filtering of water. For deeper decontamination water, filtered through ion exchange pitches. Defluorination method. Defluorination of water spent filtering through anion exchange filters. Frequently for this purpose, use activated aluminum oxide. Sometimes for decrease in concentration of fluorine, spent dilation the water of other source not containing fluorine or containing it in minute quantity. Fluoridation, artificial addition of fluorine. Spend until 1/10 of fluorine in water less than 0.7 mg/liter with the purpose of preventive 1/10 of caries over teeth. Fluoridation of water are reduced with disease caries on 50–70% in 2–4 times. Chemical tablet methods. The use of tablets and solution are widely used for the disinfection in the expedition and hikes. Tablets halazone contain chloramine, stable during the storage. The tablet is introduced to a certain volume of water, usually it's 1 liter, water and stirred every 3–5 minutes. It can be used in 30 minutes, but this tablet cannot be enough for a very contaminated water. In this causes can use tablet chlor-de-chlor, which contain more chlorine and dechlorinated agent in the middle of the tablet, sodium hyposulfite. They introduce 1 tablet to the water and stir it every 2–3 minutes. After dissolving, of the external part of the tablet is central part inactivates the surplus chlorine. If the water is very sharply introduced, 2–3 tablets at once. Iodine-containing preparations are widespread in tropical countries. They disinfect water from bacteria, many viruses and cysts. The simplest method is the disinfection by 10% solution of iodine. 2 drops of such solution are introduced in 1 liter of very contaminated water. For protection water source, in the sanitary practice applied sanitary protection zone. Sanitary protection zone is the territory adjacent to water supply source and water intake facilities, and the special regime is established there. The purpose of sanitary protection zone creation is to protect the water supply source from bacterial and chemical pollution. The sanitary protection zone consists of three belts or zones: a zone of a strict regime, a zone of restriction, and zone of control or observation. For underground water source, only first two belts are usually organized. The first zone or zone of strict regime include a territory of location of water intakes and the territory in which are the aqueduct, headworks, pumping station, water treatment plants, clean water tanks. This area is shielded and protected. Access to another person is prohibited. Forbidden to stay in the zone and keep it animals, cats, dogs. The whole area should be planted, canalized with good heat precipitation from the zone below the water intake site. Within the first zone is forbidden the use of pond for any purpose: bathing, washing clothes, taking the eats, watering cattle. For personally required periodic medical examination, screening for carriage of the vaccine, the strict observance of rules of personal hygiene, and sanitation knowledge in accordance with the volume of work defined. Second zone, restriction zone. Low water, annual, recurring, seasonal, low state, low flow of water levels in rivers. In the temperature and high latitude distinguish summer and winter low water. They may even in the second zone of sanitary protection zone, the identification of objects polluted the pond and the construction of facility for cleaning and disinfection of wastewater. In the second zone is controlled placement of settlements. At 10-50 km above the water intake place in 200 meters of the coastal strip of arable land is prohibited for resident manure or pesticide. Bathing of people, watering cattle, washing clothes are allowed only in the place established by the sanitary authorities. The second zone of sanitary protection zone in the underground source range from 50 to 1,000 meters and more. It depends on the extent to which protected the exploded aquifer from contamination from the surface. Is forbidden to carry out works related to the potential for contamination of groundwater. The second and third zone introduced to prevent contamination. The river water tip zone restriction lay upstream for tens of kilometers is a creation for establishing the boundaries of accepted speed of process of self-purification of water bodies from organic and bacterial contamination. Complete that during the summer low water needs of 2-4 day running of water. Thank you attention.